Hi guys, in this tutorial I'm gonna solve question number 1, Jan 2020 M1. Two particles P and Q of mass M1 and M2 respectively are moving on a smooth horizontal plane. Particles are moving towards each other in opposite directions. So it's better to show that which will be positive direction and which will be negative. You have to know which is moving positive direction and negative direction. If we use, this is the positive direction of motion. We have two particles, P and particle Q. It's given moving towards each other. Two particles P and Q of mass M1 and M2. Mass M1, mass M2. This is mass of each. M1 and M2 are moving on a smooth horizontal plane. The particles are moving towards each other in opposite directions along the same straight line. When they collide directly, immediately before the collision, both particles are moving with speed u. So the initial velocity of each, the first one is u, but the second one is negative u because both move in opposite direction. The direction of motion of each particle is reversed by collision. So reversed means this particle move in this direction and this particle move in this direction by the collision. Immediately after the collision, the speed of Q is third u. Speed of Q is third u. Find in terms of M2 and u the magnitude of the impulse exerted by P on Q. So to get the impulse on Q, the impulse on Q is equal mass of Q, final velocity of Q, initial velocity of Q. So mass of Q is written M2. Velocity of Q is third u. Minus u, simplify, your answer will be 4/3u, negative is positive, multiplied by m2, so the final answer is 4/3 m2u. He asked to get your answer in terms of m2 and u. Part B, find in terms of m1, m2, and u the speed of P immediately after the collision. If we use the speed after the collision is V, its direction now is negative, so will be negative V. When you apply the equation of momentum before and after, before is equal to after. Let's start now. Mass of P is m1, and its velocity is u. Mass of the second particle is m2, and its initial velocity is negative u, is equal to mass 1, its velocity is negative v, plus mass of 2, and its velocity is, after the collision, third u. Try to simplify and get the value of v. Negative Vm1 move to the other side to be m1 v1 is equal to third m2u, move to the other side, minus will be plus um2 minus m1u. Simplify m1 v1, or you can rename it v. m1 v is equal to, we have here 2, we can combine to be 4/3 m2u minus m1u. You can divide it by m1, so v is 4/3 m2u minus m1u, all divided by m1. You can remove the fraction, you can multiply by 3, 4 m2u minus multiplied by 3 will be 3 m1u, multiplied by 3 will be 3 m1. You can also take u as a common factor, so 4 m2 minus 3 m1 all divided by 3m1. This is the final answer of part B. Asked to find in terms of m1, m2, and u the speed of B immediately after the collision. Hence, show that m2 is more than 3/4 m1. From the result found, now this value have to be positive because we already substitute from the beginning that V negative. You can switch and start to write only V and use this part to be negative. But because I substitute from the first part that V is negative, so I need this value to be positive. So 4m2 minus 3m1 have to be more than 0, which subject he asked to find, show that m2. So to try to get m2 subject, 4m2 is more than 3m1. So m2 is more than 3/4 m1. That's it. He asked to show that. Thank you.